Good evening. Thank you, BBC, for having me here, and thank you, Pluralsight, for roping me in. It's a pleasure to be talking. And thanks for having me virtual so I don't have to fly in there. Today, I'm going to be talking about lessons learned building React applications. And I'm Adhithi Ravichandran, and I'm a software consultant, and I've been building React Native, GraphQL applications for a few years now. So this is a quick collection of lessons that I'd like to share with other fellow developers who are working on React. All right, let's get started. So with React, what is very cool is it is a JavaScript library, and we typically use that to build rich user interfaces. You could build web applications, mobile applications using React Native, and so on. What is very, very interesting is that React is flexible. And this flexibility comes with a lot of cost as well. It's flexible where you have freedom to choose state management, navigation, server-side rendering, and so on. And this is what brings in a lot of developers towards React because they can pick and choose the different tools that come with React. But as a developer, there is a small cost to it. Because now, since React is so flexible, I'll have to make many decisions on the project along with my team members. I would have to think about things like state management, performance optimization, testing, different tools. Do I need to use Create React App? Do I need to use Next.js? And so on. There's a lot of decisions that we as React developers have to make, which you wouldn't have to do in case you picked other frameworks like Angular, because it is a full-blown framework versus something like React is light and it is a library. So some of the lessons that I'd like to bring forth, if you're picking React for your project or you're already a React developer working on your project, these are some quick tips to just keep in mind. My first lesson is use functional components. Today, we have two concepts in React. One is class components, and the other is functional components. As of React version 16.8, they introduced the concept of hooks, which makes functional components much more appealing than it was in the past. So if you're getting into React and you're seeing a lot of documentation, blog posts, video tutorials, and so on, you'll see class components everywhere. And class components are truly a story of past, and I wouldn't recommend class components as the way to go forward for anybody getting into React. So class components are also confusing to understand as a new developer, and they're also confusing for the machine itself. So if you already have code written in class components, don't worry about it. Going forward, write your components using functional components. And if you're just getting started, don't even learn about class components from React. It is really the story of the past. Now, what I mean by class component is this, where you use the ES6 class, and we have the render method within the class component, and it comes with a huge list of lifecycle methods as well. So this is what we're moving away from in React, and don't want any new components really written in class components. The way forward is the functional component. As you can see here, it is a JavaScript ES6 function that returns a React element. Now, with functional components, what I really like about it and why we should use it is simpler to learn and write. As a developer, it's easier for me to understand and model it mentally with a functional component versus a class component. And you'll notice that with functional components, there's far less code. So you don't have huge amount of lifecycle methods, render methods, and so on. So you don't need to memorize any of that stuff. It is also easier to maintain and test. And finally, with the addition of hooks, you can get all of the React features within your functional component. What I mean by a hook here is a special function. Those of you who don't know, a hook is a function that lets you hook into React features within your functional components. Now, some of the hooks that come out of the box with React are use state, use effect, use context, reducer, and so on. There's a lot more hooks, And what's cool is you can also create your own custom hook depending on what your use case is. And all of these make functional components truly the future of React. This is an example of a functional component I've written. It is a yes, no button component. What this essentially does is it displays two buttons, yes and no. And you can see here that we use what's called the use state. And this use state is a hook that is going to track the state. So for those of you who've used the class components, this is like this dot state. So we're moving away from this dot set state or this dot state. Instead, we're going to use the hook use state. And clicking on yes would trigger an event, and clicking on no would trigger another event, which would set the button state. Now you can also write these functional components with arrow components if you prefer that. And it's pretty much doing the same thing as the previous one. Now here you'll notice that the code is much lesser. We don't use this dot state. We don't have render methods. We don't need to worry about where the component mounted and so on. So it's a lot cleaner, a lot easier. And as I mentioned, it is truly the future of React. So lesson number 1, use functional components if you're getting started with React, or if you're already in a React project, at least make sure that your new components are functional components. Class components haven't gone away, so you don't have to spend your time refactoring, but you can still go ahead and write your new components using functional components. Lesson 2 is break down your components when needed. Now, there are 2 ways to write your React applications. You can have one giant component, right? And nobody's stopping you from having a humongous component for your application, but it's not ideal. We'd want to split up our component as much as we can. At the same time, it is a layer of abstraction, right? So we don't want to split up the components to the point that it is costing you something. So here are some of the rules I follow when I decide when to break down components. First things I look for is managing state becoming a nightmare? So if state management is really hard for a large component, it's time to break it up. If I notice performance concerns where I'm re-rendering huge portions of the application, it makes sense for me to then break it down into smaller components so we don't have this giant re-rendering of the application. If code readability takes a hit, it's a good time to break down your components. And if you're working with multiple developers on a code base, if you're working through this huge component, imagine all of the git merge issues that you're going to end up with. So that is a good time to also split your components into smaller pieces. And if you're noticing that testing code is becoming an aftermath or it's harder, again, it's telling you a story that, hey, your components have to be broken down. So this is a set of simple rules I follow. When I encounter any of these, I know that I need to split my component into a smaller piece. Now let's take a look at this Twitter example. If I were to componentize something like this Twitter screen I see here, here's how my mental model would work. I look at the left side, there seems to be like a navigation bar. I look here, there is a tweet button, and I see there is a search bar button. There's also like suggestions on who I need to follow, followed by a Twitter feed. There are different items here on this UI that I can easily split up into components. Here's how I would develop the component hierarchy for something like this. I would have the app at the root level, and I would have multiple child components such as navbar, search bar, suggestion, feed, and within them, there would be layers of other children too, as well as follow within the suggestion. I would have a tweet button within feed, followed by a like button. Now, each of these components are also reusable. I could have the tweet button in several other places. I could reuse it. I could reuse the like button or the suggestion button. But this is kind of how I would model this component hierarchy. And remember that React is a parent-child relationship. So it goes top down, and ideally we want the hierarchy to follow the top-down approach. In the end of the day, each component is a building block that is a reusable piece of UI. So I'd like to put them together, resulting in a complete application. Again, you don't have to split down components to the point that it becomes harder to maintain either. So you need a good balance on where you need to stop splitting your components. Excuse me. Lesson three. In the past couple of years, I've been using a lot of TypeScript and have become a really big fan of TypeScript. I used to originally do JavaScript and React, but now switching to TypeScript has been a lifesaver. Here are some of the reasons which are very compelling to me to continue to use TypeScript and also encourage others to use TypeScript. First things, catching problems early on. With TypeScript, you can catch your problems as a developer within your IDE, where it's going to complain to you, hey, this type is missing, this prop is missing, this is incorrect, and also see compile time errors versus if you were to use JavaScript plain, you're going to see only runtime errors. So this is a huge, huge benefit. Also, the IntelliSense will be much more accurate because now you're working with a type system. And with that, your code is also easier to refactor. The code becomes readable. It's also easier to maintain and test. So there's a lot of perks coming with TypeScript. And eventually, when you've written your code, you can also generate high quality documentation with tools such as TSDoc. Here's an example of a component which is written in TypeScript. It looks very similar to a JavaScript component, except it is typed. Notice here that I could use an interface or the keyword type and declare the type for the props that I'm going to pass to our component. I'm going to call it message props, and there are two fields here, text and important. And text here is of type string and important is of type Boolean. And notice how we pass that to the message component, and now the message component says, hey, to me, you need to pass the text and important of type message props. Now, once you invoke this message component, what ends up happening is you have to pass in these two props. If you miss a prop, your IDE would complain, or if you give the wrong type, let's say you send important of type string, it's going to complain. So this basically does prop validation right then and there, which is really useful for React components. The next lesson is start with local state. A lot of the teams I work with usually have simple applications and they don't need to have things like Redux or MobX, Xstate, or any of those things. These are cool to have. These are needed only when needed. So if you're starting out, you have your application, always almost start with just local state. You don't need to worry about bringing in other state management libraries because today, if you look at tutorials and blog posts, they talk about Redux and other things. So you assume that if you're bringing in React, you have to bring in Redux or MobX. But that's not the case, and that is usually reserved for complex applications. So my key towards state management is always start with local state. By local state, I mean the state within your component that your component needs. And as the state changes, the component would re-render and so on. And if you were to pass it to child components, then make use of what's called the props. So you pass down the state via props if a child component needs it. And this usually is sufficient in most applications. Now, if you notice that some non-child components need it, then I would recommend lifting state up for those components that need that data. Now, if all of this is there and you still need more, then I would go for something like context. Context is where you have state for the entire application, and it would be part of the whole application tree. If none of these work and you need something more than this and your application state management is getting complex and you can't handle with simply just context, then you could probably go in for other options like Xstate, Redux, and so on. A quick note on what context is. Some of you may already be using it, but for those who don't, context is to share data which is global across the tree of your React components. So if you don't want to do prop drilling over and over again, passing props from parent to child, you could use React context. And there is also a use context hook that you can tap into. And this basically is typically used for things like demographic information, theme settings, language settings, and so on. So again, keep in mind that you don't have to complicate state by bringing in external libraries unless that is really your last resort. The next lesson, my slide isn't moving. Okay. Lesson 5, understand when React renders. So this is really important to designing a performant React application. So these are the times when React really re-renders a component. When state changes within the component, when prop changes, when your parent renders, or when context changes. These are the 4 times when React would re-render your component. Being aware of this is really important for you to start designing a performant application. There are different quirks you can use to optimize your performance. You could use something like pure components that would help with optimizing your performance, or you could use React Memo. The only time you can use React Memo is to stop re-rendering when prop changes. So if your component renders the same result for the same props, and you know that for sure, then I would recommend using something like React Memo. And what this does is it'll let React skip rendering of that component and just simply reuse the latest rendered result. And this is only for performance optimization, so I wouldn't rely on it to prevent renders as such. And finally, the lesson that I really value, last but not the least, is testing. Try to test your application as much as you can as you keep developing your components in your application. And don't think of testing as an aftermath, because nobody, sometimes we don't have time, we have deadlines, and we put testing towards the end. I like to keep testing as a part of the sprint planning. If you're following the sprint methodology or whatever methodology you use, make sure testing is accounted for and you talk to your team and have that as a part of your coding practice. There are 3 types of testing that I usually do with React applications. One is unit testing, and my preferred method is using Jest. The next one is component testing using the React testing library, which is really good at testing React components. And finally, and complete end-to-end test, which is automated using something like Cypress. Once your application's fully ready, you can have automated end-to-end tests versus manually testing with a QA. So keep in mind that testing is really important, and that's where you catch bugs. That's where you basically fine-tune the quality of your code. And based off the State of JavaScript survey from 2021, here are some of the popular testing libraries. I don't know if you can see them very well. I can read it out to you. It's Jest, Mocha, Storybook, Cypress, Jasmine, Puppeteer, Testing Library, and so on. You can go into that survey and see more information on it. And you can pick what works for your team. And I'm a big fan of Testing Library and Cypress and use that on all of my projects. And it's been great for coverage. It's been great at catching bugs, issues, and so on. So test as much as you can. And with that, I would like to thank you for giving me this opportunity to speak to you virtually. It's been a pleasure. I have some courses on Pluralsight. You can look for my name, Adhithi Ravichandran. It's most of my courses are on React, React Native, GraphQL, and Cypress. Do check them out if you're interested. And again, thank you so much, BBC, and thank you, Pluralsight, for having me here. If you want to reach out to me or connect with me, I'm active on Twitter at Adhithi Ravi. Feel free to reach out, and I'm here for questions as well. Thank you.
Thank you, Adhithi.